Today we're going to be looking at the Algebra 1 Chapter 4 Unit 2 review. We're going to go through select problems. So here we go. We're going to look at question 1. The table shows the relationship between the number of sports teams a person belongs to and the number of free time, or the amount of free time the person has per week. Is this relationship linear? Well, to determine if it's linear, we're just going to check the pattern by looking first at in this case, the number of teams is our x values, or domain. Free time is our y values, or our range values. We see that the domain values are going up by 1, and as those domain values go up by 1, we then look at the pattern for the y's. Well, to go from 44 to 36, they're subtracting 8. Then they subtract 8 again to go from 36 to 28. And they subtract 8 one more time to go from 28 to 20. This is a constant subtraction pattern, and since it's constant subtraction, it is linear. All right, so describe the relationship in words. Well, we kind of just said it. As the number of sports teams increases by 1, the amount of free time someone has decreases by 8. So as x goes up by 1, y decreases by 8. What I'm more interested in is describing this with an equation. And so we talked about this earlier in the chapter. We've got a general equation format where it's y equals some quantity times x plus something else. In this case, the quantity that gets attached to the x is your constant change. In a later chapter, we'll talk about this. This is essentially your slope. So this would be -8. The value that gets added at the end, we've mentioned, is our initial value. So where x is 0, this initial value here of 44 is what has to be added to our pattern in order to make this equation work. So our equation for this relationship is y equals -8x plus 44. Question 2. The ordered pairs 1, 5, 2, 9, 3, 13, 4, 17, and 5, 21 represent a function. Write the function rule that represents this function. So same idea. We're going to look for the patterns. So going from 5 to 9, that pattern is adding 4. To go from 9 to 13, adding 4. To go from 13 to 17, adding 4. And then 17 to 21, they're still adding 4. So just like the previous problem, we now know that we've got y equals 4 times x. It's that constant change. This is linear. The only problem is we can't see our initial value because we don't have x equals 0 yet. But what we can do is we can work backwards. If we were adding 4 to our pattern, working backwards means we're going to subtract 4 from this 5, so that way at 0, our initial value was 1. So this is 4x plus 1. Question 3, same idea. You've got ordered pairs of 1, 3, 2, 9, 3, 27, 4, 81, 5, 243. As we go through, we see they're adding 6, but then they're adding something that's not 6. So this doesn't seem to be linear. They're not adding the same thing. So let's double back and think about like multiplication. To go from 3 to 9, you multiply by 3. 9 to 27, you're multiplying by 3. 27 to 81, multiply by 3. Then 81 to 243, multiply by 3. Because they're multiplying by the same thing, this goes into one of our shortcuts for what is essentially a non-linear equation, or pattern. This is just going to be y equals 3 to the x power. And if you want to go back and check, you can. Plug in 1 for x, you get 3 to the first power. That works for the first set of points. Plug in 2 for x, you've got 3 to the second power, which is 9, so that works there. Plug in 3 for x, 3 to the third power is 27, and so on and so forth. All right, so we're going to jump down to question 6 now. Crystal earns $6.50 per hour doing lawn work. Write a function rule, which is another way of saying an equation, to describe the amount of money M earned as a function of the number of hours H spent doing lawn work. How much does Crystal earn in 4.5 hours? So there's 2 parts to this. The first thing we want to do is write our function rule or our equation. In this case, they've listed M as being our dependent variable, H is our independent variable. So if we want to write this in function notation, it's going to be M of H equals, and in this case, the only quantity we have is the $6.50 per hour. So this $6.50 is going to get tied to the H. So we're going to get 6 6.50h or 6.5h works, and that's our equation or function rule. The next thing we want to talk about is how much would she make for 4.5 hours of work. So that means we're going to take m of 4.5 equals 6.50 times 4.5. And we get that for 4.5 hours of work, she's going to earn $29.25. Here we have question 8 and 10, which are done very similarly. I'm going to focus on question 8. I may do 10 if I have time, but let's just look at 8 first. They want us to graph this function using the domain values of -2, -1, 0, 1, and 2. These are our x values. We're going to plug into our equation for x and see what y we get out as a result. So if this is the case, and I'm going to use this middle space where I'm going to do my work. So for the first one, it's like y equals absolute value of 2 times -2 plus 2. And we've got to figure out what y equals. 2 times -2 is -4. We've got the absolute value of -4 plus 2, which would just be 4 plus 2 in the end. So y would be 6. So at -2, our y value is 6. We're then going to repeat the same idea for, let's say, -1. So -2 times -1 plus 2. 2 times -1 is -2. So the absolute value of -2 plus 2 is going to result in 4. So at -1 for x, y is 4. And we just keep this pattern going. So at 0, we would have gotten 2 as a result. At 1, we get 4 as a result. And at 2, we get 6 as a result. This is an absolute value equation, so we should remember that our graph is going to look like a V. So then we're going to go and graph these points. So -2, 6, -1, 4, 0, 2, 1, 4, and 2, 6. And so this is our graph. And remember, something like this would be considered nonlinear. It has a turn in it. Question 10 is done the same way. You're going to plug in values from -2 to 2 to see what your corresponding y values would be. And so in this case, you've got -3, and so we'll just do the first one. So for -2, so f of -2, you've got -3 times -2 plus 4. -3 times -2 is a positive 6, plus 4 would be 10. So f of -2 in this case equals 10. And then you're going to do this for all of the other values. So at -1, we should get a result of 7. At 0, we should get 4. At 1, we should get 1. And at 2, we should get -2. The -2 10 point won't fit on our graph, but we can get the -1 7 on there. And then we can graph the rest of the points. And so this is very much a linear function. All right. Question 11. Bob has a business repairing computers. He charges a flat rate of $35 for each home visit and an additional $40 per hour for work that he does. Write an equation for the total cost C for a home visit of X hours. So we know that C is the total cost, and then X hours, we're going to say $35 for the home visit with an additional $40 per hour. So that 40 gets the variable. The 35 is just an initial fee, a one-time purchase, and then 40x. So this is what our equation begins to look like. So now, if we want to, we could then go ahead and fill in the chart. So for 1 hour of work, you've got 35 plus 40 times 1, which would be $75. For 2 hours of work, 35 plus 40 times 2, which would be $115. 3 hours of work, you're going to get $155. And then here it says N, where they want us to replace x with n to just create the expression. So we could write something like 35 plus 40n. And that's all it is. It's the same thing as we have here. We've just changed out the variable. Question 12 says create a mapping diagram that represents the relation -8, -6, -5, 2, -8, 1, and 7, 3. State your domain, range, and is it a function? So remember, domain, those are our x values. So domain in this case would be -8, -5, and 7. We don't need to list the repeated -8 here in our domain when we list it out. Range are our y values. This is -6, 2, 1, and 3. So for our mapping diagram, we're going to put domain on the left, range on the right, and we're going to kind of track where they go. So domain, we'll put -8, -5, and 7, -6, 2, 1, and 3. So based on the ordered pairs, we know -8 goes to -6. We know -5 goes to 2. We know -8 also goes to 1. And we know that 7 goes to 3. So the question then arises, is this a function? Well, as we can see when we started off, the -8, our domain value of -8 was used twice. It has two different outputs or two different range values. We can also see from the mapping diagram, it has two lines coming from it. So this is not a function. All right, next up, question 13. We've got f of x equals 61x represents the number of words you can type in x minutes. How many words can you type in half an hour? Well, remember, half an hour is 30 minutes. So that means in this case, x is going to equal 30. So we're just evaluating. We're plugging in 30 to see what we get. So we've got f of 30 equals 61 times 30, which in this case is going to give us 1,830 words. All right, so we're going to jump to question 15. It says find the range of f of x equals -2x plus 6 for the domain of -1, 3, 7, and 9. So a lot of this can be done either calculating for every single one of those domain values. It can also be done through the same thing we did with the graphing where you're setting up an XY table or chart. So I'm going to kind of do both at the same time. So -1 is my x, 3, 7, and 9 are also my x's. And I'm going to find my y values or my outputs in this case. To do that, I'm actually going to just evaluate the function -2x plus 6 for each of those values. So if I start with -1, and I plug -1 into that equation, I've got -2 times -1 plus 6. -2 times -1 is a positive 2, plus 6 would be 8. Then I've got f of 3, so that's -2 times 3 plus 6. -2 times 3 is -6, plus 6 would be 0. Then I've got 7, so -2 times 7 plus 6. -2 times 7 is -14, plus 6 would be a -8. And then last but not least, -2 times 9 would be -18, plus 6, which gives us -12. These values are our range values. We could also then accompany them over to our XY chart and showed where each of these went. So from -1 we go to 8, from 3 we go to 0, 7 we go to -8, and 9 we go to -12. But either way that you go through the process of solving this, understand that the y values or your outputs or your f of x values in this case represent your range. So 8, 0, -8, and -12. All right, question 18. You have 8 cups of flour. It takes 1 cup of flour to make 24 cookies. The function c of f equals 24f represents the number of cookies that can be made with f cups of flour. State the reasonable domain and range of this function. So right now they're telling us, just by reading it, that the f represents our independent variable. and they've given us the function rule they want us to use. If we're thinking of just the independent variable, which in this case is what's going to affect the domain, we can kind of list out our possibilities for usage here. So in this case, we have 8 cups of flour. Let's say we decide to make no cookies. We could use 0 cups of flour. Or we could make a little bit of cookies. We use 1, 2, 3, 4, 5, 6, 7, or 8, all of the flour we have. So our domain is related to the amount of that independent variable we choose to use or have at our disposal. So anywhere from 0 to 8. Then your range is going to be, as if you plugged in each of these values into this particular function, what did you get back as a result? So if you decided to make 0 or use 0 cups of flour, you're going to make 0 cookies. If you decided to use 1 cup of flour, you could make 24 cookies. If you use 2, that'd be 48. 3 is 72, or yeah, 3 is 72. If you use 4 cups of flour, we're going to go 96. 5 cups of flour, 120. 6 cups of flour, 144. 7 cups of flour would be 168. And then 8 cups of flour, 192 cookies. So if we're thinking about this and we wanted to label it to make it easier to remember, this was the flour we used for domain, and these are the resulting cookies were our range. All right, 19 through 22, maybe 23 as well. We're looking at indicate if the relation represents a function. So for the first one, for 19, this is a graph of what could be a function, and we're going to use the vertical line test. So as we look at this from left to right, if we draw a vertical line anywhere on the graph, we're going to see that it only ever intersects the graph at one point at a time. Because of that, this is a function. This passes the vertical line test. For question 20, notice that your domain has 3 used twice, but the 3 then goes to 2 different outputs. This is not a function. In 21, all of our domain values are used once and they go to an output, so this is a function. In 21, if I draw a vertical line right here, that's not very vertical, but works, it intersects the graph in 2 points. Because it intersects in 2 points, this is not a function. And then instead of a table or a graph, we look at a set notation here. As we look at this, we can look at we're looking at the domain values, and we see that 3 is used twice. 3 goes to -2 and 3 goes to 1. Those are different outputs. So in this case, this is not a function. I'm going to do 24 real quick. We look at our domains. All of the domain values are used once. So we should be pretty good, and this is a function. All right, I'm going to hop down to question 28. What value of x could be used to ensure that the following relation is a function? So we want it to be a function. In order for this to be a function, all we have to do is remember that each domain value goes to one range value. So ideally, we just want to make sure every x value of our ordered pairs is used once. So in this case, we've already used 1, 4, and -2. So as long as we don't repeat one of those values, this will be a function. So x can be any number, except 1, in this case 4, and -2. Yep, it can be any number except 1, 4, and -2. Question 29, are the following linear or nonlinear? So to be linear, it has to be a straight line, or it has to have that constant addition or subtraction pattern. So as we look through this, we've got primarily just graphs here. The first graph, we can see that this is a line, so this is linear. No turns, no nothing, this is definitely linear. For B here, we've got the graph of a parabola. Parabolas have turns to them. They have turning points. It changes directions. This is nonlinear. Question C, we're looking at it, and as we check the pattern here, it's going -2, oops, -2, -2, -2. That's a constant subtraction, so this is linear. And then question D, this is the absolute value graph. It looks to start off linear, but then changes directions. The change of direction makes it nonlinear. And then as a bonus here, it says, what type of functions are represented by graphs A, B, and D above? Well, we said A was a line or linear. B, this is a parabola, which is a quadratic. And then D, this is the absolute value.